So this is a question from the 2018 High Level Maths Paper 1, and we're going to look at question 1. So we're not going to look at part A because this this problem here, is one that most students should be comfortable with. Instead, we're going to look at part B, which is an inequality problem, which does pose a problem for many students. So we're given the inequality here, 2x minus 3 over x plus 2 is greater than or equal to 3, where x is a real number and x cannot equal to minus 2 because we can't divide by 0. Now, the most important thing that we need to realize is, well, first we need to get rid of the fraction that we have here. But in order to get rid of the fraction, we need to multiply both sides by x plus 2, right? And that essentially cancels out the denominator here. But we can't just multiply it by x plus 2. We need to multiply it by x plus 2 squared. Now, why x plus 2 squared? Well, if we multiply both sides by a square number, it gets rid of any negative possibility. So we're always stuck with a positive number. So that's essentially the reason why we multiply both sides by the denominator squared. So if we go ahead and do that, we get 2x minus 3 over x plus 2 by x plus 2 squared is greater than or equal to 3 by x plus 2 squared. These two cancel, so we're ultimately left with 2x minus 3 by x plus 2 is greater than or equal to 3 by x squared plus 4x plus 4. And this would give us 2x squared plus 4x minus 3x minus 6 is greater than or equal to 3x squared plus 12x plus 12. Now, at this point, all we have to do is move everything onto one side and have the left-hand side equal to 0. So if we do that, we'll get minus x squared minus 8x, not minus 8x, so that should be minus 11x, minus 11x, and then we have minus 18 is greater than or equal to 0. Now, at this point, what we should know is that we don't want a minus sign in front of the x squared. So all we have to do is we can just multiply all across by a minus, and that would change the sign of everything. But one very important thing to remember is when you multiply or when you change the sign in an inequality equation, is the greater than or equal to sign needs to flip as well. So that would give us x squared plus 11x plus 18 is less than or equal to 0 this time, right? Now, at this point, what we need to do is we want to factorize this. Well, why do we want to factorize it? Because when we factorize it, we are able to identify where the roots are. And based off of that, we can draw a quadratic curve and see whether we're looking on the top half of the curve or the bottom half. So if we go ahead and factorize this, we should get x plus 2 and x plus 9. And from this, we know our roots are x is equal to minus 2 or x is equal to minus 9. So I'm going to draw a little diagram here, and we have minus 9 here, minus 2. Now, so the question is, are we concerned with this portion of the graph up here, or are we concerned with this portion of the graph? Well, we go back to the equation that we have here. So essentially what we're saying is take the quadratic equation and look at the graph for which all of these values are below 0, so below this line. So we're not actually concerned with this part, we're concerned with this part here. So that would be here, right? So now we need to look and find a range of values for x that if we sub in here is going to give us an answer of less than or equal to 0. So all of our x values, or the range of values, will involve this minus 9 or minus 2. So if you think about it, in order for the graph to always be below this line here, x needs to be less than minus 2, or x needs to be greater than minus 9. Because if you think about it, if I want x to be less than minus 2, I'm traveling backwards, which is this region here, and the graph is below. And then we're saying that x also needs to be greater than minus 9, which is going this way, which means the graph is also below the line here. The opposite, say if for whatever reason we make a mistake and we say x is less than -9. Well, if we think about this number line here, we're looking for x values that are less than -9. We're going this way now. Now, if we go this way, let's look at the curve. Well, the curve is also traveling this way as well, and it's above this line here, which means it's actually greater than 0. So that isn't the right answer. So the answer should be x is less than -9 here, right? And now at this point, all we have to do is we should just combine our answers here. X is greater than -9, sorry. So that would give us x is less than -2, greater than or equal to -9. Now, this last part is quite important, and it's a part that's often overlooked. So one very silly mistake a student might make at this point is they would say, well, the answer should be x is less than or equal to -2. Well, that's wrong, because we're told initially that x cannot equal to -2. Now, even if they didn't tell us this part, we should still know that, well, if for whatever reason we think -2 can be subbed in for x, then you're dividing by 0, which is undefined, and you're breaking the rules of mathematics. So our final answer should be x is less than, strictly less than -2, or greater than or equal to -9.